Alright, so not too many problems today, or actually not too many difficult problems. It's just a little refresher on percent problems. Tomorrow you'll have more, but let's see where we start. So I think the first page deals with rates, so we can start with those. And I need to get a calculator. 1 second. Vivian wants to buy some watermelon. Kingston Market has 10-pound watermelon for $3.90, but the farmer's market. So again, we want to compare, in this case, which place has the better watermelon. And let's pick a color. And we have King, and I'll write King. And the other place is called Farmers. Okay, so King has $3.90, and you can buy a 10-pound, $3.90. Okay, and this is pounds. And Farmers you can buy $4.44, and you can buy a 12-pounder. Which one is the better? Well, as it is right now, I don't know. So let's change both of them to unit rates. So let's find out how much 1 pound costs in each supermarket. Alright, so 10 to become a 1 is divided by 10. And obviously, if you divide the top by 10 and $3.90 divided by 10, that's easy enough. 39 cents. So 1 pound at King Supermarket is 39 cents. The other one is divided by 12, top and bottom, and 4.44 divided by 12 will give you 37 cents. Not much of a difference, but, sorry, 0.37. So the better buy is at Farmers because it's 37 cents, and that's question 1. And question 2 is what's the difference between the two unit prices? Well, the difference is 2 pennies. Okay. That was the top question. The bottom question. Mitch needs to purchase soft drinks for his party. He's trying to figure out the cheaper. Is it 12-pack or 20-pack of soda? Well, the 12-pack is $3.99. You get 12 sodas. Okay, dollar sodas. And the other one, you get a 20-pack and you buy $5.48. Who makes these numbers up? All right, anyways. And 20 sodas. So again, very hard to find out or to determine which one is cheaper in the way they are represented right now. But let's find out how much each soda is. So the $3.99, you divide top and bottom by 12. 12 divided by 12 gives you 1. And now I'm going to divide $3.99 by 12. And that gives you our magic number of 12, which is 0.3325. And that just rounds to 0.33 cents. Okay. The other one, it's $5.48. And you're going to divide that by 20, and because you got 20 sodas, obviously, and it's 27 cents per soda. So you're better off buying these ones because it's a little bit cheaper. Okay, and what's the difference between them in total? Well, the difference is 33 cents, 27 cents, and the difference is 6 pennies. Okay, but then again, if you don't need 20 sodas, you might as well just buy the 12. So eventually it's going to be based on need as well. Okay, and here we go. AAA batteries, 60. What? Why does it need 60 triple? Well, anyways. Oh, interesting question. He needs to buy 60 batteries, so we want to find out where it's better. Alright, so 20 AA batteries. Okay, so $12.49, and you get 20. I have a feeling it's a trick question. And then 12 batteries for $7.20. I don't know if you're gonna use a unit rate here because you want to buy 60 batteries. So let's try something else here. Okay, so 20 is $12.49, and if you change it to 60, it would be times 3. So let's do times 3 on the top, and that's going to give you 37 something. $12.49 times 3, it's going to give you $37.47. So if you needed exactly 30, you would spend $37.40 here. Okay, notice I'm not doing unit rate. I'm actually changing this, making it proportion. So same thing here. From 12, I want to go to 60 batteries. Okay, so 12 to 60 is times 5. And we're going to multiply 17.20 times 5, and that's going to give us $86. Yikes! Really? Right, obviously, it's much cheaper if you need exactly 60 and nothing more to go to the first store where they sell it by $12.49 for every 20. Okay, so I didn't do a unit rate here. Okay, because not necessary. It's a little bit different. Okay, and they sell it in packs. Okay, but question B says, what's the difference between the cost of one battery? Okay, in that case, you would need to do the unit rate, and that's let's do a unit rate. So here, 20 batteries, you pay $12.49. You want the cost of one battery, so it's divided by 20, and 12.49 divided by 20 gives you 0.625, which ends up being 0.62 cents for one battery. And in this one, let me take that sign out. Okay, it's 17.20, and you're going to divide it by what? By 12. Wow, talk about difference in price. And one battery over here, in this is $1.43. Much more expensive. What's the difference between the price? Well, it's about 81 cents. Not about, but it is 81 cents. Okay. Second question. Let's see if I can lower the. Can I lower it? Okay. Alright, so, and then we're going to page 112. 87. Let's just make click here on top. And center. Alright. So, I'm going to make something different today. So, the code today is going to be different because some of you, I've heard, are going straight to the end of the video and looking just for the secret word. So I'm going to do parts. So the secret word is made up of four words today. First word is Wednesday. Alright, so let's continue. Use a tape diagram to answer the following questions. Okay, 80% is what fraction of the whole quantity? Well, if you look at the picture, okay, and you have something that's like this, and it's divided into 5. Okay, 1, 2, 3, 4, 5, and they have numbers on top. That's 0, that's 0, 1, 2, 3, 4, 5, and they wrote 20, so it's broken up in 20s. 40, 60, 80, 100. So 80%, let me move this just a little bit. 80% is what fraction? Well, 80% would be the first 4 boxes right here, or 4/5. Okay, so 80% equals 4/5 of that. So you can say I ate 80% of that chocolate bar, or I ate 4/5 of that chocolate bar. Second one, 1/5 is what percent? Well, if you took 1/5 of that chocolate and you ate 1/5, you ate 20% of the chocolate bar. 50%. What would be 50%? Well, 50% would be right here. And 50% is between 2 and 3, which is 2.5. So what's the fraction of the whole quantity? 50% would be 2.5 over 5, or actually just half. And finally, 1 is what percent of the whole quantity? 1 is what percent? Oh, when 1 would be 20% of the whole quantity. Why would they ask that question again? It's the same thing as question 2. Okay. And 112. Now we're going to 114. 114. Ooh. Yikes. Okay. You have a table, and let's just do this. So 3/8, you want to change it to a decimal, and you want to change it to percent. Alright, I'm going to do a few of these long way, but I'm not going to do all of them long way. So 3/8, how would you change 3/8 to a decimal? Well, the easiest way is to divide numerator by denominator. 8 goes into 3, no. Add a 0, add a decimal, which allows you to add a 0. 8 goes to 30, yes it does, about 3 times, which is 24. Come down 6, bring another 0 down. 8 goes into 60, 7 times, which is 56. 4 left over, add another 0, bring it down. 8 goes into 45 times. So 3/8 is the same thing as saying 0.375 as a decimal. And as a percent, how do we change a decimal to percent? The easiest way, you can multiply it by 100 or do the same thing, or just move the decimal 2 spaces to the right, and that becomes 37.5, and you add the percent sign, percent. Okay, the shortcut is moving the decimal 2 spaces to the right, or you can just multiply by 100, which gives you the same answer. Second line is 0.35, so that's easy. 0.35, we want to change it to percent, it's 35%. And from this to a fraction, okay, look at the last place value here. The last place value is in the hundreds, and it's 35 over 100. The other one says 84.5%. Okay, how do we change this to a decimal? You move the decimal to the left this time, and that becomes 0.845%. Okay, if you move it 1, 2. Okay, and how do we change this to a fraction? Look at the last decimal place, the place value of the last digit, which is in the thousands, and 845. And we're not going to simplify it. Okay. And the next one, 0.325. Let's change this to a percent. Move the decimal to the right, 1 of those, and becomes 32.5%. And as a fraction, again, look at the last digit. The last digit is the thousands. And you can write 325 on top. Okay. And this is how you read it too. So how do we read this number? That number is 325 thousandths. Okay, that's what I wrote as a fraction. And then 2 over 25. How do I write that as a decimal? Well, you can divide. Okay, one option here is to divide 2 by 25, or you can change this. No, you can't change this. Or actually just division. 2 divided by 25, which be 0.08, or as a percent, 8%. Okay. 6. Choose one of the rows from the conversion table in exercise 5 and use models to prove your answers. Yuck. To prove my answer. Let's see. Which model would I pick? That was me. I would pick the first one, 3/8. Okay. 3/8. Let me just go back a couple of pages. So in 3/8 we had 0. Bad number. No, too long of a decimal. Yikes. You should use a 10 by 10 grid. Oh, we can use a 10 by 10 grid. So you know what? In that case, let's use this one. Okay, it says you can use a 10 by 10 grid. So by using a 10 by 10 grid, oh, that's gonna get ugly because I have to draw a 10 by 10 grid. Alright, so let's see what I can do here. So I'm gonna take 0.35. Okay, and I'm going to draw the ugliest 10 by 10 grid ever. Okay, it's supposed to be a square. 1, wow, 2, 3, 4, 5, 6, 7, my goodness. Or I could just 7, 8, 9, 10. 8, 9, 10. Yikes. Okay, 1, 2, 3, 4. That's straight. 5, not so straight. 6, straight. 8, 9, yikes. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need one more. So that would be a 10 by 10 sort of. Okay. 10 going across, 10 going down. And you have 0.35, and you want to change that to a percent, which is this way. The percent means a ratio compared to 100. So out of 100 boxes, how many would you shade? You would shade 35, which would be 10, 20. Okay, I'm not going to shade 30, and then 5 more. 1, 2, 3, 4, 5. Okay, and this would be as a fraction. No, as a percent would be 35%. Okay, I can use that as my proof. Okie dokie. So, page 114, go to page 116. Wait, I need this. Percent of a quantity. 5 of the 25 girls on our soccer team is our 7th graders. Find the percentages. Alright, so 5, you can write it this way. 5 out of 25 girls are 7th graders. So total, and these are the 7th graders. So I have total 25 kids, 5 of them are 7th graders. We want to know what the percentage is. So if you had a team of 25 people, what's the percent that is 7th grader? Well, one way of doing it is like this. And you can use a percent proportion. So let's compare this to 100. Okay? 100 is something compared, it's a ratio compared to 100. Okay, is there a relationship here? Yes, there is, which is times 4. And you're going to do the same thing. On top times 4, which is 20. So 20% of the team is 7th graders. The other way of doing this would be to divide the numerator, 5, divided by the denominator, 25. Okay, so imagine, for example, you got 5 out of 25 on the test. You want to show your parents what the percent is. So you would divide top by bottom. So 25 does not go into 50, so you add a 0, you add a decimal, allows you to add a 0. And 25 goes into 50, 0.2. Okay, which is a decimal, and you're not done yet, and you would then change this to a percent, which would be 20%. You got choices, the first one or the second one. The second one has 2 steps. You have to divide first, find the decimal, and then change it to percent, which is not that big of a deal. At the bottom one, of the 25 girls, okay, so let's use a percent proportion, fill it up. So here we go. So of the 25 girls, so we know that there's a total of 25 girls, 40%, and I'll write that on the top, are also play on the team that travels. So 40%, what does 40% mean in terms of number of girls on the team? So if there are 25 girls, how many of them are on the travel team? Well, we know 40% is them, so it's a little bit less than half. Is there a relationship here? Yes, there is. 100 to 25 is divided by 4. 100 divided by 4 gives you 25, and you're going to do the same on top, which is 10. Now, yeah, a little bit low, less than half of the team. So 40% of the team means 10 out of the 25 girls. Uh, 117, we're also doing this page. Okay, soccer team. They won 80% of the games this season. So this is nice because nice good practice on this percent proportions. Okay, especially because there's a relationship with the numbers, I think. So let's see. 100 goes over here, and you know that 80%. So they won 80% of the games. Not bad. And 80% actually means 12. It translates to 12. So how many games did they play? So they won 12 out of how many? And we'll put a question mark over here. Okay. So let me just charge. All right. So hang on a second. Ooh, is there a relationship between 12 and 80? Good question. Let's see, we can divide this by 4. No, there is no relationship between 80 and 12. I don't know if there's a nice whole number relationship, so let's find out, and let's ask our old friend, The calculator, 80 divided by 12. No, there isn't. If I cut that in half and make it 8 and 12, what about if I make it 40 and 50? What if I make it 20 and 25? That also doesn't work. What if I made that 160? That also doesn't work. 160, 320, 540. No, that's not gonna work. 540. So let's do this. All right, so we're gonna have a problem here because there is no relationship between 80 and 12. Not one. It's a decimal, and it's an ugly decimal. So let's see if we can do this. Let's keep this side obviously as it is, but over this side, is there a way of finding an equivalent fraction that we work with 12? So let's say I reduced that and made that 40 over 50. So instead of writing 80 over 100, I write 40 over 50, which is the same thing. Okay. Now, is there a relationship between 12 and 40? No, there isn't. What if I reduce that again to, from 40 and 50, I can go, if I reduce 40 and 50, I can go 4 over 5. Divide top and bottom by 10, right? So basically, I'm taking 8 over 100 and I'm dividing that by 20 and dividing this by 20. And my fraction that I'm going to use, instead of 80 over 100, I'm going to use 4 over 5, which is an equivalent fraction. I'm allowed to do that. Now, is the relationship between 4 and 12? Yes, there is, which is times 3. Now I do the same thing at the bottom, times 3. And that gives us 15. So the total number of games that they play was 15. And how much did they win? They won 12 out of 15. Okay? Let's just see what the bottom. Wait. Okay, no. Okay, this one. There are 60 animals exhibits at the local zoo. What percent of zips does each class represent? Animal class represent. All right, so where is it? 116, 117. Okay, so there's 60 animals here. So let's see the mammals. The mammals represents 30. There are 30 mammals out of the 60, so half of the zoo is mammals, or you can say 50%. That's easy enough. 15 out of 30 are reptiles and amphibians, so you can say 15 over 60, which is 1 over 4. And you can divide 1 over 4, but hopefully you know that 1 over 4 is 25%. Okay. Fish and insects is 12 over 60. Okay, 12 out of all the animals in the zoo are fish and insects. Divide that by 60 because that's the total. You can divide and get your answer right away as a decimal, or you can reduce this and know that this is 1 over 5. And 1 over 5 translates to 0.2, which translates to 20%. And finally, birds is 3 out of 60. There's only 3 birds out of 60, and 3 out of 60 is 1 over 60, 1 over 20. Okay, and if you divided 1 divided by 20, you would get 0.04, or simply 4%. No, I'm sorry, 0.05 or 5%. Okay, all these, if you don't know your benchmark fractions, memorize. If you don't have them memorized, you can divide 1 divided by 2, which you'll get 0.05. I'm sorry, 0.5, which if you move the decimal 2 to the right gets you 50%. 1 divided by 4 gets you 0.25 as a decimal, which eventually becomes 25%. 1 over 5 becomes 0.2, which becomes 20%. Okay, 17 and our last page. So today was actually really easy. 123 coming up. Let this load. And second word of our code here is the word is. So you have the first word, this is the second word, which is. So let's look at the question, and it says, Mr. Yoshi has blank papers, he graded blank papers, and he had a student grade test, the rest. What percent of the papers did each person grade? Excuse me? And Mrs. Bennett had blank of her blank student's paper. How many papers does she still need to finish? What are we supposed to do here? Okay, you know what? I guess we'll call it. We don't have to do this because our values are not here, or they're not given values. I don't know if we're supposed to give any. So I guess we'll call it is. And 123 you don't have to do because I don't know where the values are. Okay, so tomorrow we'll do more percent problems that will include tax tips, and I think that's it. Tax and tips. So for today, that's it. Okay, so all classes. You had page 86, 112, 114, 116, 117. And some of you had that handout. 633, 601. Okay? So I might as well, I thought I had one more page, give you the rest of the code. So the rest of the code is going to be, and I'll write it here. Okay? Word is pi. And on the next screen is your fourth word, which lovely. Alright, so you had 4 words that make up your secret sentence. Alright, that's it. I'm going to load this to YouTube and you should have it soon.